Hi, everyone. We are ready to kick off right about now. My name is Lindsay Hooper, and I'm the Marketing Communications Manager here at Augury. We are so excited to have you joining us today to discuss the ROI of predictive maintenance. Return on investment is something that affects every business, and we're really pleased to have our very own Jonathan Biagiotti here to discuss not only calculating, but communicating ROI. At the bottom of your screen, you'll see a chat and Q&A function. Feel free to use either to engage with questions throughout the webinar. At the end of the presentation, John will be answering the questions that came through. So with that, John, I'm gonna let you take it away.
Thank you very much, Lindsay. Really happy to be here today and talk about return on investments and not only how to calculate it when you're thinking about investing in predictive maintenance, but also how to communicate the value of that ROI. So I'll jump right in. A little bit about myself before we get started, just so you have some background of who's speaking today. So I've been at Augury for about 2.5 years now. We're a predictive maintenance solutions company. I fill the product marketing manager role here, which means primarily working to commercialize industrial IoT products, a lot of customer development and market research work to find, discover, and implement value for our customers. A little bit about my background. I have an engineering background, previously in the semiconductor industry for IBM, where I completed lean green belt training. I have a Harvard MBA and a BS in electrical engineering from Yale. So a little bit about the agenda to get our bearings before we get started today. So I'll talk first about preventive maintenance and the differences between that and predictive maintenance, which is what we are going to focus on today. Talk about some examples of how different stakeholders define ROI, the process for determining ROI that I've found to be pretty effective, and then I'll go through some real life examples of determining the ROI of a predictive maintenance project at Hologic. I'll focus on downtime there. I'll talk about repair costs and energy efficiency. And lastly, how to communicate ROI effectively within your organization. And that's related to the ROI and how that changes over time. And then at the end, we'll have about 10 to 15 minutes of Q&A. So first, I'll talk about the differences between preventive versus predictive maintenance. And this is really relevant because the process of ROI helps you quantify the benefits of moving from PM to PdM. And as you can see from the chart, even though it may seem like a subtle jump, the ROI can actually be financially material for an organization if the project is structured properly, right? So up to 10 to 100 times cost savings in going from reactive to predictive maintenance, and 10 times cost savings going from preventive to predictive maintenance. And the reason why previously you may not have been looking at or seriously considering predictive maintenance in the past, which is up here in the ultrasound, magnetic, and vibration and oil analysis area, is mainly because in the past it was a very expensive investment, very time consuming, required a lot of skill to implement, and just the cost of sensors was very high. Nowadays that's dropping dramatically, so that it doesn't make sense only for the jet engine industry, but it makes sense a lot more for the commercial and widespread industrial industries. So preventive maintenance is a time-based maintenance program. Predictive maintenance is a condition-based maintenance program. So time-based versus condition-based. And we'll get into how that actually affects your ROI. And what I want to focus on here is that predictive maintenance is not just smart sensors. It's a holistic solution that is maximized when it's implemented at the plant level. So having individual insights on the condition of a machine not only gives you insights on the machine, but when it's scaled out to the site level, increases the opportunity for additional ROI. So comparing various machines within the plant to one another highlights opportunity for additional ROI and helps you uncover best practices amongst various areas and then propagate them to the rest of the plant as you find them. It also helps teams keep engaged and improves communication between operators, maintenance professionals, and engineers by tracking those uptime and maintenance metrics that we're going to go over in a little bit. So expanding to the site level, helps you prove out your ROI that you come up with as you're coming up with the investment calculation, but it also helps you find hidden sources of ROI that you may not have been aware of before making this investment. And we'll go over that in a real life example later in this webinar. So why should you care about coming up with a rigorous process for calculating ROI? And bottom line, it's because you don't want to invest in projects that lose money, right? So proving out ROI not only prevents a poor initial investment, but it actually can help an organization track performance during the project's duration, right? It clarifies the metrics to watch, and it helps the organization and the people within it know how they're constantly performing against those initial calculations. And so it'll let you know when those metrics are in or out of spec, right? So really it's the old phrase, if it's not measured, it's not going to improve, applies a lot here, and is a lot of the value of going through the process of formally putting an ROI value on a predictive maintenance investment. So when we talk about ROI, what does that mean? ROI, return on investment, can mean lots of things to lots of different stakeholders. So I want to get them all out in front of us on the table right now before we jump in and start defining more specifically ways that I found it to be effective. So for example, you may have heard from a finance professional that the net present value of this investment is greater than zero, right? And this is essentially the opportunity cost of spending money on predictive maintenance versus another project that you're considering, right? So do all the benefits and the costs today, when brought back to the value of money in today's dollars versus tomorrow's dollars, make sense? Is that greater than zero? So the finance professional might be looking at it from this standpoint, the opportunity cost standpoint. Another simple way of looking at it is payback period. So the payback period is less than 8 months, right? So this is the time it takes for the dollars gained to equal or exceed the dollars invested in a predictive maintenance program, right? And the beauty of this metric is that it's very simple. It's very easy to understand, and therefore a lot of plants will have a heuristic like things must pay back within 2 years to make sense. It's a very simple and easy way of measuring ROI and making decisions. Another thing you might hear is that production increases will be 5% if we invest in this predictive maintenance program. Now, this one is purely focused on the output. And even though it's less considering the initial investment, it highlights the fact that people care about how this is actually going to change what I'm producing and how is this going to increase revenue or reduce my costs. Another one is percent payback on a predictive maintenance and program. So we will see 165% return over the cost of this program. This is typically the one that I like to focus on, mainly because it's simple and it's easy to calculate. It's gain minus the cost over the initial cost, right? So how much money did I gain divided by the difference between what I gained and put in over what I put in. So we're going to focus on this mostly in some of the spreadsheets you'll see later. And the last one I want to mention is similar to an output metric that we saw with the production output, but in this case, it's a repair cost declining by $92,000 over the last year. So this is another example of an output metric that someone might want to track. Now I'll go over the process of determining ROI as I see it, and a way in which I found it to be very useful for various different stakeholders to go about doing this. So I try to break this down into a 5-step process of determining ROI when investing in predictive maintenance. The first step is really understanding the problem. So determining from historical data a baseline of your current situation at your plant to really get a sense of what is the potential ROI going forward. So understanding the current problem and your current state of affairs at your existing location. Next, it's actually outlining the ROI metrics of interest to your organization. So there's an entire list of things you could be tracking and trying to improve. So setting that definition up front and going through that list exhaustively helps highlight those. Then after you've defined sort of what you want to track, then you have to define what targets you want to hit within a certain time period and properly set expectations within your organization to do that. So once you have the potential, you understand your current situation, you have the metrics you want to track over time, and you've set everyone's expectations, it's now time to actually implement the predictive maintenance project and continuously track those metrics, and in some cases, update your ROI expectations and model after you've learned more information. And then lastly, it's about communication. So choosing a champion to communicate the results is going to be critical here, so that people not only see the value of the initial investment, but they see the value in continuing to expand and implement predictive maintenance throughout your plant. Right? And typically there is significant value, so this is very important to keep that going forward into the future. Okay, so the first thing I want to talk about is understanding your current situation so that you can understand the potential outcome of a predictive maintenance investment. And basically, the first step in doing this is understanding. And the best place to do that is in data. So looking at historical work orders for repairs or maintenance activities that have been filed, looking at current preventive maintenance checklists and practices, looking at current route schedules, and by interviewing the people closest to the machines, that's the operators and the maintenance teams, for their perspective on where there is waste in the process. So waste can either mean waste in time, quality, or production output, right? So looking at the historical data, it's, these can be downloaded or maybe they're kept on a clipboard somewhere. Listing those out is the first step. And then the next step really is sitting with a reliability professional to assess where predictive maintenance could have impacted this historical data, right? So where could work orders have been prevented? Where can condition-based maintenance activities have eliminated the need for a preventive maintenance task, for example? And then how much can that change? Can that be changed or be reduced, right? So once you have the historical data and you look back and see what could have been affected, you can start to put numbers on the potential impact of a predictive maintenance program. And so on the right here, you could see for preventive maintenance task optimization, you might be aligning a particular piece of equipment several times a month. And that takes you 15 labor hours, and the cost is in materials is about $3,000. And what you'll do is you'll assign a score from 0 to 100% for that task on how much it could have been reduced by implementing predictive maintenance solutions and technologies, right? Similarly for work orders, up here you can see a chiller. If you reduce the percentage of chillers in danger from 8% to a target of 4%, and we'll go over how to set those targets, the difference in savings on those repair costs can be significant. Here it's $25,000, but in other cases it can be more. So one thing to note here is that this does not depict downtime events, and typically downtime could be a significant cost savings when you're evaluating predictive maintenance. So keep that in mind, and I will get to that later in the webinar. So I'm going to talk about tangible ROI metrics now to be aware of. As you've now understood sort of the historical impact of predictive maintenance, you want to define what metrics you want to track going forward. And I like to bucket this into three main buckets, and I'll start with repair costs, right? So this is avoided repair costs as a result of condition-based maintenance, right? So catching problems earlier versus late stage, and therefore fixing them when they're less expensive to fix. Another thing to note here is extending equipment useful lifetime. So this is, you may have an ASHRAE standard that says this piece of equipment lives for 15 years. By maintaining it optimally based on the condition of the machine, you may be able to extend that useful lifetime and defer a capital investment. The second out of the three buckets is downtime. So this is typically for an industrial setting, one of the main sources of value in an ROI calculation. And that's reducing unplanned downtime, so reducing fires that you have to put out. But it's also planning for and reducing planned downtime. So every machine will need to be down at some point for some maintenance, and it's about planning for that and reducing that time as much as possible. It's about increasing production output and avoiding risk. So risk is what is the potential consequence of a failure and what is the probability of that failure, and how do we reduce both of those numbers? And then the third bucket is preventive maintenance resource optimization. So this is eliminating unnecessary activities and risk associated with those activities, reducing labor time based on condition of the machine versus a time-based recommendation to maintain the machine. This is reducing overtime on emergency jobs and covering more with fewer resources. So if you're short-staffed, it's about how do you cover more machines, or if you have an existing program, it's how do you get more out of that existing program with the use of technology. And then there's sort of a miscellaneous bucket of other things you can consider in an ROI calculation, including spare parts inventory reduction, energy efficiency, and OEE, overall equipment effectiveness, which is a formula for availability times performance times quality of a machine. So all of these metrics can be impacted by a predictive maintenance program and should be considered in a ROI calculation. However, these are not the only things that you should be considering. So whereas tangible metrics might be very easy to put a number on, intangibles are still pretty impactful when you're thinking about how to calculate and think about ROI. So first and foremost, there's safety benefits. So you're not, by basing your maintenance on the condition of a machine versus on a time-based recommendation, you're actually not touching machines that are healthy when they actually need to be maintenance according to a time-based recommendation. So if it's healthy and it says to grease a bearing every 6 months, but the condition is acceptable and you don't need to, you're reducing the risk of a workplace injury from someone tampering with a machine that does not need work. And you're also reducing the risk of introducing something to that machine that can later cause a failure or safety incident. So you drop a wrench into the machine. That's an extreme example, but I think it serves as a good analogy here. It's about morale and retention of knowledge. So you're actually empowering your operators to understand their machines and maintenance professionals to work more efficiently and effectively to validate their work so that when they've made a repair, they can validate that machine has been improved in health. People retire and they take that knowledge with them. So having that stored in a solution and a platform helps you retain that knowledge of those machine experts. It's about continuous improvement. So setting a mindset that monitoring everything keeps deviations from a standard very obvious and increases internal satisfaction because it changes the dynamic from firefighting to first time right between teams. It's about innovation. So looking for new ways to accomplish financial goals and not being caught off guard as a laggard behind your competition. And it's about really brand building, right? So you're going to be known as a company that's using cutting edge techniques and technologies. It's a selling point for your customers. And it's also gives you the ability to attract top talent who want to work with an organization that's investing in their future, right? So there's a lot of intangible ROI metrics that you should be aware of as well. So I talked about 3 different buckets of ROI. So how do these come together to calculate a holistic ROI? And what I want to talk about is how to optimize ROI with total predictive maintenance coverage. So the first bucket was preventive maintenance cost savings. So too much of a good thing can actually be a bad thing. Over maintaining your machines increases that unnecessary downtime by taking the machine offline to conduct unneeded PM tasks. And it also introduces that additional risk that I mentioned before. So going through an ROI calculation can help you move from the right side of this graph down to the left side. Now, repair costs, you don't want to go too far to the left because as you do, you're going to be under maintaining those machines, and that may lead to unnecessarily high maintenance repair costs because you're fixing problems at a later stage than at an earlier stage, right? So that ROI calculation helps ensure that you don't go too far to the left of this graph and you stay towards the middle here. And then that last bucket is downtime savings, right? So if you're over maintaining your machines, they're down more than they have to. If you're under, they're producing poor quality products and also down more than they have to be, right? So it's about optimizing for this middle area here, and ROI helps you pinpoint where that middle area is. So once you have a sense of what ROI metrics you want to track, one thing to do is define the goals in transitioning from preventive to predictive maintenance. And one way I like to do this is to put your current situation and your target situation on a 1 to 10 scale, right? And this scale is based on the current distribution of health of machines within your facility. So on the left here, you can see there's 53% of machines unacceptable and the rest need some sort of maintenance. And then you could work through this to determine your target distribution of machine health, right? So that means at that target level, you're getting higher overall production output and higher quality products. A key part of this is that it's a holistic approach to your current situation, and that by monitoring these assets with sensors, you instantly get the health of your machines, right? Without having to do an exhaustive manual assessment of all your assets, right? And you track this over time in real time. So as these change, this is automatically updated. Setting a timeline is going to be key. So typically I've found 3 to 6 months is long enough to see some initial success stories in a predictive maintenance program. And it's about comparing your machines to what they are today to how they can be in the future, and doing that on a variety of inputs, right? Okay, so once you have your plant sort of pegged at a 1 to 10 scale and what you are today versus what you want to be in the future, it's time to actually start implementing the program. So far we've talked about repair cost savings and savings from optimizing current preventive maintenance activities. However, in most cases, that real value is going to be in higher production output. So this is reducing that downtime, both planned and unplanned. So one thing to note here is there's always going to be downtime. You have to maintain machines at some point, but the goal is to minimize and plan for that. So Toyota, which is sort of the gold standard in terms of manufacturing, stops their lines constantly throughout the day by operators pulling an ending cord, right? But the key is that it's for a short amount of time where intense, fast improvements are made. So by having a predictive maintenance system, you can plan for those planned downtime activities. And so now I'll talk about an example, real life example of how to evaluate and track downtime savings metrics through a case study that we've actually seen here. So I'm going to talk about Hologic, which is a medical device manufacturer. They make breast and skeletal implants. So it's a highly critical facility. Things have to work and produce high quality product for human life, really. So they're a leading edge company. They've invested in predictive maintenance to monitor their critical air handling units that are servicing the uptime of their clean room, right? So they have a clean room, they have to meet FDA cleanliness standards, and these air handling units ensure that this clean room stays operational. Unfortunately, there's also limited redundancy on these air handling units, and they're hard to access just by the nature of the equipment, right? So they chose to remotely monitor and diagnose these in real time with sensors. And as a result of this, they actually found a bad bearing on an air handling unit and replaced it at a planned interval, right? Instead of firefighting and having the plant be down at an unexpected time, they were actually able to proactively get in front of this and make this improvement at a planned time. So what is the impact of being able to track and update your model in real time after you find a success story? And so what they did here is they essentially saved $53,000 in downtime by getting ahead of that problem with their predictive maintenance system. So the way they figured, it's no spare motor available. This could have resulted in a clean room downtime of up to 3 days. And so when adding up the lost hours of production and to get the clean room back online, plus the overtime cost of doing that, they get to about $53,000 in avoided downtime, right? So they implemented that into their ROI model and updated that going forward. Another aspect of that is the repair cost savings they saw out of that. So actually by finding this problem, they found a similar earlier stage problem on another air handling unit And instead of actually replacing that entire piece of equipment, they were able to send that out for repair and have that repaired at a lower cost than total replacement, right? So there was sort of an added benefit on a different piece of equipment with the predictive maintenance system. And one thing to note here is that these numbers could have been drastically different if this was detected at a time closer to the end of their quarter, typically when they have higher capacity needs in the plant, right? So this could have actually doubled if this were during that high capacity time and they needed to have an unplanned downtime event. The full details for this case study, by the way, are available by reaching out to us through our website, right? So if that's something you want to dig deeper into and really look at the raw data here, please feel free to reach out. Now I'll talk about another example of tracking those ROI metrics from the repair cost savings and the energy efficiency standpoints, right? Okay, so here's a very interesting example. I believe it was from a critical facility such as a hospital. And what you have here is a chilled water pump. So on this pump, they actually took a recording and diagnosed the pump in alarm here. That's this first dot right here. They made a repair, so they re-greased the bearings. It was showing bearing wear. And then they took another recording with their predictive maintenance solution, and it still was in alarm, right? So that was pretty confusing to the team. You know, I just made a repair. Why hasn't this improved as I thought it would? So upon further inspection, they found that the grease port for this pump was actually clogged because a year ago, someone had put the wrong lubricant into the machine, right? So the grease was actually not ever getting to the bearing. And this ended up, you know, causing the bearing to be in severe or alarm, and they had to replace this bearing. Now, one of the benefits, sort of they uncovered some of the hidden risk of this because it had 3 other pumps just like this sitting next to it, all with the same problem. So they had the wrong lubricant that was used in the grease port, and their grease ports were clogged, right? So they actually were able to catch those in an earlier stage of bearing wear in monitor. And this actually allowed them to properly grease them so that they saved those other bearings and those other pumps from having to be replaced, right? So a full-scale rollout here actually uncovered hidden sources of risk and actually improved their ROI numbers just by the fact of expanding their predictive maintenance program, right? So there's some hidden value that comes out as you work through a predictive maintenance investment, and it requires you to constantly update your ROI model. Now, another added benefit of this was energy efficiency, right? So when vibration increases, energy efficiency actually decreases. And I have a statistic here that I found very interesting from the Alexandria Engineering Journal. And basically it's saying that as you increase vibration levels, your equipment efficiency is going to go down and your energy efficiency is also going to go down, right? So typically it's hard to calculate the ROI and the energy efficiency values of a piece of equipment. So if this were a chiller, for example, you would typically need power consumption data, liquid flow rates, temperature differences across an evaporator. But here there's a clear correlation between increased vibration energy due to bearing wear and decrease in energy efficiency. So if the machine is not operating in an optimal condition, you are wasting energy, right? So that is definitely something you need to consider. And really the same theory applies to driving a car with deflated tires. You're wasting gas because you're decreasing your fuel efficiency, right? So energy efficiency is something that definitely should be built into an ROI model. And there's certain techniques that you can use to correlate vibration with that energy efficiency. So now I would like to focus a little bit on communicating the value of ROI. So now that we've gone through various ways of understanding the current and future target states of your machine health in a plant, and we've reviewed some example calculations of repair cost savings, preventive maintenance optimization, and downtime savings, I want to focus on how to communicate those savings throughout your organization, So ROI, like I said, can mean very different things to various stakeholders within an organization. Now I'll start with an example from a bottling plant that required us to show different aspects of the same ROI model to the various decision makers, right? So it was the same, different sides of the same coin, but it was still necessary to show those different sides to satisfy the needs of the different stakeholders within the plant to make the initial investment into predictive maintenance. And I'm sure that as you go through your own projects, you're going to have similar challenges, and it's just useful to get a little creative in how you present different data to different stakeholders. Okay, so here's a bottling facility, and really the stakeholders here are the finance department and the asset managers. That's the maintenance and the operations teams responsible for these assets, right? And so this is what the finance department was concerned about. And the key takeaway here is that it was based on hard historical data, right? So the finance team could not use assumptions. It had to be based on hard historical numbers. And it's significant because think about it from a standpoint in a factory, right? There's a problem, a maintenance professional goes, and he's not concerned about paperwork first. He's concerned about going and fixing a problem, right? So what will happen is they'll go out, fix the problem, and then after the fact, they will open up a maintenance ticket saying, okay, I found this problem. And then 1 minute later, they will close that ticket out with the task that they did to resolve the issue, right? So in the system, it's showing 1 minute of downtime, right? Where obviously that's not the case in reality, but unfortunately, some stakeholders require that hard data and that hard evidence to make calculations. So, okay, there's still other value to be shown, and that's what we'll focus on for this particular stakeholder. So what they focused on here is the hard savings by preventable historical work orders, right? So you see the 54% here and 63% here of repair work orders and emergency work orders could have been impacted by a predictive maintenance program. And this is the dollar value associated with 54% reduction in those work orders, right? So that's a hard value, a historical number to focus on. And it's what they needed to do this. They also focused on excess inventory reduction, right? So this is the line, the top line here, 53,118. Now this is not a theoretical calculation. It is based on hard numbers because this team happened to have a very clear industry benchmark on what spare parts inventory should be for similar plants, right? So this is spare motors, spare pumps, spare gearboxes for eventual equipment failure. They had benchmarked this data and they took their current inventory levels of spare parts, subtracted out the benchmark data, and set that as their target ROI number, right? And that was verified by a reliability professional that a PdM program could have actually impacted and helped reach that target spare part inventory level, right? So these are all hard numbers based on historical evidence that the finance team could use to justify the investment. One thing to note is that by investing in predictive maintenance, there were not any labor savings that the finance team saw, even though the asset team was utilizing their human capital more efficiently. So since no one was actually being laid off, and in fact, their team was actually being used more effectively and covering more assets and maintaining the plant better, the finance team doesn't see an impact on payroll, right? So that was something that the finance team cared less about, but for sure, in terms of resource optimization, the asset team cared a lot about. So let's talk a little bit about what that asset team actually cared about here. And the two things that I want to highlight here is the potential at scale and the fact that this data is based on actual data closer to reality that we got from expert interviews, right? So the asset team is willing to put a more realistic assumption for work order and labors to complete a job, and therefore got a theoretical but potentially more accurate assessment of the downtime savings within their ROI calculation. So it's that labor hours per incident number here that they were a little bit more flexible on because they realized that the historical record may not project reality here. So it's also what they cared about was at the unit economic level, they wanted to highlight the effects of scale. So if the unit economics worked for a line within this plan, then expansion to the site-wide level, where there were 4 or 5 different lines, could also increase that ROI proportionally, right? So going from about $150,000 worth of value to 460 as they scale this program out. So it helps paint the picture of the vision and the potential of investing in a predictive maintenance program. So they cared about the scale, and they cared about an accurate assessment for what downtime looks like in reality, even if that varied a little bit from their historical hard data record. Okay, I'm going to shift gears a little bit and talk about just communication in general, right? So this is a graph that Gartner is famous for putting out, and it shows really that at the beginning of a project, there's very high expectations. Everyone's very hopeful, but then right after implementation of a project, people start to get a little bit disillusioned, and mainly that's because a new technology or a new solution, or there's some change management aspect in there that requires people to go and exceed a learning curve, right? So you change how people have done things in the past. There's a learning curve, and for a short amount of time, it's going to affect their productivity. And that's really what this trough of disillusionment is. Now, eventually you get through that and you become more productive, but this is really the highest risk area you have when implementing an PdM program, and where the ROI becomes very, very important. So ensure the key here is, while you're in this trough of disillusionment, after you decide to invest in a predictive maintenance program, you have to ensure that you invest enough in effort and time to see the minimum value required to prove out a wider implementation. So you wouldn't just try to learn a new language for a week, and if you hadn't become fluent within that week, quit and say it was a failure, right? It's clear that you would have to invest at least a minimum amount of time to see success. To truly evaluate the ROI of a project. It's at this point that the communication and reinforcing the ROI that you've already calculated becomes critical, until you build those success stories, and that you make sure you don't backslide into the old ways of doing things in the past, right? And this eventually becomes easier as people see the value, and as it's being created and they see the evidence by whatever metrics they're tracking that we already went over earlier in the webinar. But it's key that you assign a champion to do this, right? So without a champion, you will not get buy-in, and it will be very hard to communicate properly the value of a predictive maintenance rollout. So this person is someone who will own the tracking and the communication of success. They will set those expectations in the beginning by evaluating the potential on that 1 to 10 scale of rolling out a predictive maintenance program. And they will ensure that you involve the relevant people or affected people from the start of this ROI calculation. So if you're not talking to the people closest to the equipment at the plant floor level, the maintenance engineers, the operators, and if you're not talking with the financial stakeholders and the management team, you may miss a key portion of the ROI calculation that will be needed to actually prove out the value of this program and the success, and jeopardize the success going forward. So the key is to prove out the success while you're in this learning curve period, so that you can eventually achieve those higher productivity outputs that you're looking for. Another word about communication. So ROI will change over time. So as you make improvements and the hard costs decrease, so as your repair costs decrease, for example, your ROI for that particular metric will level off over time, just by the nature of improving the overall health of your machines. However, this is sort of a trap, because what you should track and communicate is the cumulative savings over time, as those will continue to increase, right? So the analogy I like to use is the seatbelt analogy, right? So using seatbelts over time, over the last 50 years, has significantly contributed to deaths that arrive and fatalities that happen on the road from motor vehicle accidents, right? So What you don't want to do is say, okay, I'm looking at a graph of fatalities over time, and that has decreased significantly and has sort of leveled off. So now it's a good time to stop using seatbelts because we're good enough. No one is dying in car accidents anymore because it's improved, right? That would be absurd to think that. The same holds true for monitoring your machines, right? Just because you've actually made improvements and shown that costs have decreased, you want to continue to monitor those in the future to ensure that it stays at that low level. So the intention is to have higher reliability and fewer breakdowns. Once it's achieved, you don't want to stop monitoring these, and you want to continue to communicate the cumulative savings that you see over time. And really, these cumulative gains can be more obvious if you set clear milestones. So this is something your champion will need to do when not only evaluating ROI, but implementing a predictive maintenance program, right? So these milestones are important because they break down a project into small wins, right? They show progress and they help you understand where you are and how far along people are in the project and what they need to do to go forward, right? And see the next small win, right? So it begins with implementing a predictive maintenance solution. At Augury, it's a subscription model, but predictive maintenance takes many forms. Doing that historical baseline on your machines and understanding your current situation. That's step one of determining the ROI. It's then making the investment in an ROI, in a ROI positive predictive maintenance program, and continuously updating that based on the actual machine health and the success stories that come out of it. So here are the success stories, those early wins of problems that you've identified and been able to save in terms of repair costs, preventive maintenance optimization, or downtime savings. And then it's about scale. So uncovering those hidden risks by scaling out a predictive maintenance program and getting those operational insights that help you increase that ROI number. Right, so you're eliminating those costs. You're reducing the technical expertise that historically was required when sensors were very expensive and skills were hard to find. You're communicating the tangible immediate value. Also, the intangibles are important. Don't forget those. And you're showing out the clear and proven business case over the process of 3 to 6 months typically to get to those first early wins. So breaking up into milestones is something your champion should do to communicate ROI and should prove out predictive maintenance at scale. So that's it for the prepared portion of the webinar today. So to sum up, we talked about how to define ROI, what it means for various stakeholders, the various different types of metrics you can track. And then we went over real life examples of how someone has found these metrics, proven them out, and updated their ROI model, and then how to communicate those value. So I'll be happy to hand it back over to Lindsay, and I think we can open it up at this point for some question and answer.
Yeah, awesome. Thank you so much, John. Even I learned something there. We've had a couple really great questions come through over the course of the webinar. If I don't get to your question, don't fret. We will follow up with you separately. So to kick it off, in your experience, does this conversation change if your facility is in poor condition?
Okay, that's actually a really good question. So if your facility is sort of starting out in a better than in a worse than it should be place, typically we found that it's not really an issue with personnel. It's really an issue of just historical fact, right? So previously the cost of sensors, like I mentioned before, had been really expensive, and expertise has been hard to find and also expensive. Right, so as predictive maintenance solutions have gone down in cost, in overall cost, just now has it been making sense for facilities to invest in those projects and seeing that ROI that they need to invest in those projects. So this is something that is fairly recent. So really it's expected to uncover a lot of hidden issues and problems that may exist that just couldn't have been highlighted before. It didn't financially make sense. So this is a new change. And it actually helps you set expectations at the beginning a lot more objectively and clearly within your organization. And it gives you the chance to kind of look like and track the progress over time in real time, right? So it's expected that implementing a program will highlight things that were sort of not highlighted before. And no, basically it does not change the conversation.
Awesome. Another one. I have critical equipment of all sizes. Is there a technical limitation for deploying this type of technology?
So typically there's not, excuse me. No, there's no technical limitation in terms of equipment size. So what we see sometimes and what you will encounter when coming across a project that you're thinking of investing in and you're trying to come up with ROI, you might find that a smaller piece of equipment, say half a horsepower, is just throwaway, as you might call it. It's really cheap to replace. It's not an expensive piece of equipment. But then the key thing to consider there is the cost of downtime potentially associated with that equipment failing. So even though it's cheap to replace, you may be surprised and have to suffer some unplanned downtime if that equipment fails, even if it's redundant. And then that's really where the ROI comes into play, that avoided cost of downtime that comes with replacing that equipment, right? So no technical limitation, and typically the smaller equipment, that's where the downtime and the preventive maintenance optimization comes into play with the ROI calculation.
Great. How quickly can I, in a service company, expect to see payback on this type of technology?
Okay, that's a fair question. So if you're in charge of servicing this equipment and you own the health of that for a client, really the way we think about it, and when it comes down to calculating ROI, it's really a numbers game. And statistically, what we found is about 40% of machines have some sort of problem, whether it's early stage or later stage. That's, I showed the slides earlier with the pie chart. Just historically, that's what we found across plants. And really what that means is it's a numbers game. So if you record more machines, statistically, you're going to find problems that need to be repaired, and that will generate that service work to pay back the investment in a predictive maintenance solution, right? So if you find something on a chiller, for example, that could potentially generate years worth of value for that predictive maintenance investment fairly quickly, within a day or two, if you happen to find something with an expensive piece of equipment.
Great. And I think we've got time for just one more question. So here it is. I've got a brand new chiller with an extended warranty. What's the added value of predictive maintenance? Okay,
so say you have a piece of equipment, in this case it's a chiller, it's under warranty. If something happens with the piece of equipment, the manufacturer is liable to reimburse you for that cost. So a couple of things with that. So absolutely there's still value in predictive maintenance on this piece of equipment for several reasons. The first one is typically the warranty will cover make and manufacture defects. So if there's anything that violates the terms of that warranty, whether it's misuse or whatever it is, it's not commissioned properly by a third party that, is not part of your organization, it could be liable, right, for a problem, right? So preventing that can be huge. But say it is covered and they do maintain that and they reimburse you for the equipment costs and potentially even the labor, there's still that cost of downtime that is associated with that equipment. And that may not be covered by a manufacturer's warranty, right? So even if, you do have a manufacturer's warranty and supplemental insurance, there's still secondary effects that are associated with downtime. So for example, it's down and you're late on delivering a product. If you're in a frozen food manufacturer to a client, that's going to affect your brand and your reputation. You may even lose that client, right? Which is not really going to be captured by any reimbursement you get from a warranty. So definitely there's value in monitoring that piece of equipment, even if it's under warranty.
Okay, cool. Well, I think that's about all the time we have. We got 1 minute to spare, so we'll let everyone get going. Again, if we haven't answered your question, we can follow up with you directly after this. Additionally, keep your eyes peeled because we are going to be sending out a link to the recording and the slides for this webinar. So I hope everyone has a great afternoon or rest of your morning if you're on the West Coast, and we hope to see you for our next webinar. Thanks.
Thank you.